Hey everyone, so it's been a long time since I've uploaded anything onto YouTube, mainly because I've been busy with other stuff, personal things. But doesn't matter. No, I thought I'd try something new by sharing some of my recent things that I've been working on. So in this video, I'll be showing you how a limited slip differential works, specifically the pressure ring based clutch type limited slip differential. And as you can see, I've designed and made 3D printed my own model and it's entirely made of PLA. It's actually 99% 3D printed aside from these screws on here and two springs, preload springs. There are one on each end on this side. So I'll be going over how it works, and then at the end we'll be disassembling it. So just starts to see the internal workings and actually see the mechanism in action. But for now, before even actually getting to the differential, I wanted to give you a little bit of background on different types of differential. So when it comes to clutch type or LSD differentials, generally speaking, limited slip differential, specifically mechanical limited slip differential, because there are also electronic differentials, there are other types of differential. But generally speaking, in mechanical types of differential, there are these main types. Now, of course, there are probably there's some more types, some other different in some niche cases, like in racings and other types. But these are the general limited slip differential, mechanical limited slip differential that you find in cars and vehicles, in either performance or in regular oriented cars. So the one that I will be going over is the pressure ring based clutch type limited slip differential. So let me explain this diagram a little bit. So we have two types of mechanical limited slip differentials, which are the clutch type and the gear type. Sorry, the camera keeps on focusing. So yeah, we got the clutch type and the gear type limited slip differential. Now from the clutch type, which is this thing again, it divides into two, you can say, sub branches, which are the pressure ring based differential, and then we have the preload spring based limited slip differential, which again uses clutch types, but the actuation mechanism is a little bit different. On the other hand, we have the geared type LSD, which do not use any sort of clutch type. They are mainly the actual differential or the limiting of the differential speeds and the wheels actually taken care of by some gears. Now there are three different types of geared differentials. Now you got torsion type A, torsion type B, and also you got torsion type C, which is also sometimes known as helical differential. And I think there are some more, but these are the most common ones, I believe. But yeah, they all come with their own advantages and disadvantages, of course. That's why there are different types of them. Some of these ones, the gear one, can be very precise, but at the same time, it can be limit some. They have some limiting factors like torque capacity and other stuff. On the other hand, clutch type, they can be quite precise as well, but they generate a lot of heat, and they can be quite complex. And well, there's also maintenance involved, because after some time you have to change out the clutches inside. And yeah, and that's pretty much it. I won't be going into how an open differential works, mainly because, well, I'm pretty sure there are a lot of videos online on YouTube that explains how an open differential works in crystal clear details and with animation and stuff. And I'm sure, well, this video assumes that you already know how the open differential works. But essentially, just to give you a quick overview of basically how limited slip differential and an open differential. So you're in this kind of situation where you have, well, basically this is the front of the car and it points that way. So this is the rear axle or the front axle, it doesn't really matter. And the differential sits right in the middle, so you can think of it as basically like this inside here, right in the middle of the right and left axle. So basically, the way it works, or the reason why you need such a limited slip differential is that, imagine you're in this kind of situation where one of your wheels is in a high traction surface, say asphalt or a track or anything, and on the other end, your wheel is on a loose or in a low traction situation. So think of it as some loose dirt patch or gravel, ice. It could be anything, or the wheel could even be in the air, like momentarily. So what I'm trying to say is that this wheel has lower traction, and the other one has high traction. So generally speaking, in an open differential, all the torque that's coming from the engine will go straight to the wheel with the least amount of resistance. That's pretty much nature law that any sort of force will try to take the path of least resistance. So because this wheel right now in this moment has the least amount of traction, hence the least amount of resistance, so that all the torque will actually flow to this wheel, and you'll end up with a classic one wheel peel, and so this wheel will start turning really quickly, basically having twice the speed, and this one will be pretty much dead, and no torque will be delivered to that one. And so yeah, so limited slip differentials, as the name suggests, basically try to solve these. And as I mentioned a couple of minutes ago, there's like loads of ways that you can achieve that dependency, or shall I say, independency limitation in a way. But again, they all come with their own advantages and disadvantages. So this thing right here that I've 3D printed is the clutch type, pressure ring based clutch type differential, which again, it does have clutch plates on each end. So it has a clutch plate here and a clutch pack, I should say, clutch pack here and another clutch pack on the other end. That helps to sort of limit the independency between the wheels. So the way it works, so I'm going to demonstrate this. I'll try to demonstrate this because I also have some bearings here. I've got two bearings which are actually they're meant to go into these slots, but these parts here. But I never actually 3D printed the stand, and I thought, okay, I'll just do the video. So to demonstrate it, I just have to say that the white part is the differential, and these gray parts on each end, think of them as the wheel or the output of the differential. So, and you can see there's an arrow here indicating the front of the vehicle, or the front of the car, basically. So the differential will be turning this way in case you want to go forward. So that way would be the forward direction, and so these. So you can see the input, the engine output would be this casing. So it would turn that way in order to go forward, basically. So, and these are the wheel output, you can say, and I just 3D printed these because it's just much easier to sort of handle and manipulate. It's much more comfortable because the mechanism is internal. This actually meshes with internal splines, which I will get into shortly. And here I also managed to have some grooves or some slots in there, so as to make the mechanism a little bit visible. Now it's not very visible, and maybe you won't be able to see it all that much. But it's there, and I'll show it to you in a moment. So you can see this again. If you're driving in a straight line, everything is fine. There's no difference between the speeds of each wheel, so it just keeps rotating. You can see I have some marks here and there to indicate how the differential, each input would rotate. So you can see I'm touching the case right now, so you can see everything rotates as a single unit. Nothing is different in here. Nothing turns at a different speed or anything. But as soon as you try to negotiate a turn, say for example a left-hand turn, right-hand turn, so what would happen is your outside wheel, the right wheel would want to turn faster. So it would try to go faster than this one, and it would turn in the opposite direction relative to this wheel, in a sense. Okay, so it's not really opposite direction relative to this, but let me give you a demonstration. So the car is going forward like this, okay? The car's going forward, everything's fine. And then all of a sudden, this wheel would want to go faster. So coincidentally, also this wheel has to turn slower. And so the speed difference is kind of proportional. So if the speed of this wheel increases by, let's say, 1 unit, the speed of this wheel decreases the same, so 1 unit basically. So as you can see, this results in the wheel being able to turn in the opposite direction, pretty much. As you can see here, I am able to turn them in the opposite direction, pretty fine, no issues there. And as you can see, for example, I can turn it like that. So it's like going on a turn. So this turns much slower than this one. You can see I can still turn it with no issues. And it's also important to note that this, where's the mark? Okay, this side. I've actually added a mark here, so you can see that this, the output actually turns twice, well, 2 times, twice as fast as the actual differential case. So if I were to hold this, okay, I'm holding this one, and I want to turn this one, you can see that if I make, let me just hold it in a way so you can see. So if I turn quarter of the way, you can see that this has completed exactly half the amount. If I go half the way, you can see now the casing has completed quarter of the way. And if I go all the way around and come back to where I started, you can see that the casing is now halfway there. So this the output, each output rotates sort of like twice the amount if the other wheel is stationary. That's basically it. And so what would happen if you have one wheel with good traction and the other one with a sort of loose traction? So in an open differential, all the torque would be transmitted to this wheel. But in this differential, there are clutch types, there are clutch plates on each end, which will lock the independency, or will lock the whole thing together and will result in the whole thing turning as a single unit. So let's demo. I'm going to try to demonstrate that. So I'm keeping this, I'm holding this very tightly in my hand so as to simulate a good traction. And my hand will be turning the casing, so that would be sort of like the engine's output or the transmission's output. So, and see what happens, okay? So as soon as I try to rotate it, it locks, and I'm really exerting a lot of force right now because I have marks on my fingers, but I'm unable to rotate it either way. So I can't rotate it, okay? So this, the whole thing, sort of rotates as a single unit and locks basically, and so there's no slip. Same thing happens on the other side. So if I hold this on this end and try to rotate this, the thing locks. Like, I'm really putting a lot of force into this. My hands are, it's leaving an impression on my fingers, but I am unable to rotate it unless I rotate this one in the opposite direction, which is what a differential should do. See, I can rotate it very easily with minimal effort here, but I'm unable to rotate it individually. And I'm not sure, maybe I actually get to show it to you. See this black mark in here? That's actually one of the clutch plates. And if I were to do the same thing, I'm holding this in one hand, and if I try to turn that, maybe you'll see that. Let me see if it focuses on the camera. Okay, so let me just, you see the clutch plates moving outwards, so towards the wheel this way, and maybe, see it just a little bit. See that? It moves a little bit, and that little motion is more than enough to compress the clutch pack on each end to fully lock the whole mechanism. So basically the clutch plates will be locked together, and the friction between them locks the whole thing together. As you can see, I'm still completely able to rotate it in the opposite direction. Pretty cool, eh? So let's get to the disassembly and see if we can actually, see if I can show how each individual piece in this mechanism works. So I'm gonna get into disassembly. So first of all, let me just remove each wheel, so you can see there's the splines inside, and these are just there as like an adapter, just so that it's easier to manipulate. Same thing on the other side. So there. So this is basically like the whole mechanism. Okay, so these are the final screws. Oops, almost dropped it. So you can see that the preload spring is actually acting against me, and it's trying to pull apart the cover. See, but okay. Last one. Well, that was pretty tight. Okay, so you can see the preload spring. I actually have to like keep it, otherwise the preload spring would just kind of want to pop the cap out. So let me hold it in place. Okay, there you go. Every screw is out. So let me just put this aside. Okay, so this is the cover that holds everything. And oh, by the way, the bearings are supposed to go in like this, but I never made it stand. So okay, so now if I remove this, careful so that it doesn't, okay, there you go. So you can see, there you go, this is the preload spring on this end, and the job of this preload spring is to exert a constant force onto these clutch plates so that there's a little bit of resistance, like a preload resistance basically, so that it's not like a complete open differential even when it doesn't need to be. So basically you can tune this. If you make the spring stiffer, then the differential will be locked more in a sense, even when you're not applying a lot of torque to the actual casing. So yeah, this is the preload spring, and it can come apart like this. This is basically just on there. There's no screw or anything. It just basically just drops in place like that. Okay, so I'm just gonna put it back. So, and here you can see the left output spline on this end. So this would be your wheel. Now, this is actually a very good way. So let me try and see if we can demonstrate that. So you can see that the clutch plates are actually floating inside. They can move in and out. And this is sprung back because there's another preload spring on this end, which sort of like pushes it back. So if you try to rotate one of the outputs, or one of the outputs, independently from the other one, and just trying to keep this one, what would happen? So if I'm trying to be, okay, there you go. I can do it this way. So if I turn it either direction, what would happen is that the clutch plate, see how it just kind of popped out? The clutch plate pop out, okay? They just move outwards. And as they move outwards, they get blocked by this cap. And so as they're blocked, let me show it again. Okay, see, they're now in normal position. And if I try to, this won't pop out. So if I try to move it independently, see, it moves outwards. And that motion creates friction between every single one of these clutch plates and against this cap, or against this cover, I should say, if you will. And so that ends up making the friction inside. So let's take it apart even further. It's actually very easy from this end. I just have to push from this side just upwards, and the whole assembly will come apart. So just very careful. I don't want to completely disassemble it. Oh, okay, there you go. So you can see there's another preload spring on the inside. I'm touching it with a finger right now, so you can see this is pretty much the same as this one, except it's on the inside. And this is the casing, the whole casing of the differential. And you can see there are also slots in there. And you can see that these slots, they sort of mesh with these specific friction plates, I should say, and also these pressure rings, which I will show you in a moment. I don't want to tilt this because the whole thing will tip and the whole thing will drop. So yeah, this is basically the casing. You see the inside, nothing special. And all the shiny parts you see is grease. I had to put a lot of grease in this thing in order for it to work properly. And oh yeah, just before we get into this, I'll just put it on this side. I just want to show you that this gear, the ring gear, is actually attached to it and is removable by these 4 side screws on this side. Let's see if we can remove them. That should be enough. Okay. And the cover basically sort of attaches or bolts, screws onto the actual gear. Okay. Now if I remove them, let's see if I can. Some of these are stuck in there good for some reason. Okay, there you go. Remove those ones, and this should be relatively easy. Okay. And this one, there you go. Oops, popped out. All right, there you go. So now that these screws are also out, you can see that I can just, let's see. Oh, just screw holding it in. There you go. So you can see that I can just pop the ring gear out, and you can change this one to a bigger size or a smaller size depending on your final drive. If you want to have more acceleration, then you would increase the size of this one, or if you want to have more speed, vice versa, you decrease this one, the size of that one, and increase the pinion teeth. But well, it doesn't matter for now. So yeah, this is the casing basically. Oh, let me just remove this one as well. There you go. So this is the other preload spring. There are 2 of them. So let me just put it here. And yeah, this is like the whole casing, and this is the ring gear. I'll just put it back here. I'll just put it here. Okay, there you go, just in a messy way. So let's take a look at the core, as I like to call it. So this is the whole core mechanism and how the whole thing works. It depends on this thing. So you can see that, let me slightly open it like this. Okay. So you can see, and by the way, this is all grease. So yeah, so on the very inside of this thing actually works very similar to an open, like any regular open differential. Mind you, the helical and the gear type differentials are completely different on the inside. So yeah, so you can see that this has very similar components as to like an open differential. You can see there's a side gear. These are the spider gears. There are four of them in this here, and there's also another side gear on this end. So this thing basically meshes with with both sides, and they sort of drop into these grooves in this end. So you can see that if I try to hold them in and turn this, you can see that it sort of acts like a regular differential, or regular differential basically. So, and the other side as well. Basically, it just sort of locks into place like this. So if you noticed, I'm sure you've noticed that these slots are not just semicircle slots. There are these angles. There are specific angles in them. So you can see there's angles here, angles here. So basically, this thing, which is the core, I don't really know what else to call it. So I call it just the core, the spider rings, or the. Actually, I think these are called the pin, I believe, the spider gear pin. Well, but you get the picture. So basically, this thing can rotate a little bit. So it drops into these grooves, and these grooves are angled, as you can see, and that will be the direction, the forward direction. So you would, sorry, actually, it's the other way around. I'm sorry. So it's the that will be the front of the car. So because this thing is kind of it's kind of sitting in the grooves, but what happened is, as the car, oh, so by the way, so this thing, which is the pressure ring, this is actually attached directly to the casing, and as the casing rotates, it moves the pressure rings with it. So as it rotates, as it turns the pressure rings in that direction, or the pin or the spider gears actually lag behind, and due to the angle, it sort of pushes them. Let me zoom in so you can see a little bit better. There you go. So it kind of pushes the whole assembly outwards towards each wheel. So, by the way, the same thing happens on the other side. So you can see if I sort of hold it like that, you can see that. Let me see if I can simulate that. You can see how me turning it pushes everything away from the center. Now that motion is exactly what locks these clutch plates. They generate friction. They exert force on each and every single one of these friction plates, and it generates the friction needed to lock the whole thing in as a single unit. So let me just set this aside. So yeah, if you were to turn this like that, you can see that it moves apart. See? A little bit. So if I take this apart, these are just spider gears inside. I'm just going to put here. And let's take a look at the clutch plates and everything. So first I have to remove the spline. Let me just pull it away. It's a little bit difficult. Okay, take. So this is basically what splines into the side gear. So I'll set this aside here. And now I can kind of pull this away. There you go. So there you go. See, this is the side gear, which meshes with the core on this end, like that. And this is the side gear. Now, the side gear can move laterally, so it can move side to side. And then it is engaged with this clutch plate. So you can see there's a bit of a spacer here, just like a tuning spacer, nothing special about it. It's a 1.5 millimeter tuning spacer. So as and also you can see that there are two different types of plates. So if I can sort of remove them individually, they're stuck to each other because of the grease. So you can see you have two different kinds of plates. You have the friction plate and the clutch plate. The friction plates, as you can see, have taps on the exterior, on the outside of the plate, and they mesh with the grooves on the casing. You can see, and they are also allowed to move laterally like this, but they cannot move independently axially. So, but as you can see, they don't have any grooves on the internal, so they can turn independently from these. On the other hand, these things have grooves on the inside. So as they slide in, again, they have a little bit of space to move laterally, but they cannot move sort of axially, independently from the side gear. So, and you can imagine that the friction between this and that, as they are pressed against each other, basically locks this gear, which is the side gear, to the casing. right? It locks it to the casing, and if these clutch plates lock, it basically locks this and the clutch the diff casing together. So basically the whole thing will become one single unit because of the friction that is generated between each clutch plate. Now, the reason there are more clutch plates is simply to increase the friction and also to longevity. And you can see they're pretty much the same things. So the way you would make this is, the way you would assemble this is, first of all, you have to drop this in like that, and then you would add the spacer over here, and basically you just go with the clutch plate like that. If I can get it in there. One sec. There you go. It's in there, and then you would put this, and then again, clutch plate, your pressure plate or friction plate, another clutch plate over here, like so, and a friction plate like that. Oh, and I also forgot about the first one, so you'd have to drop in this one first, and then the rest. See if I can actually get them aligned again. There you go, more or less. Okay, there you go. Well, more or less, you get the picture. This is how it's supposed to be. So this is the assembled part. This is the other side, and you can see it's assembled. So yeah, these are the taps and pressure rings. So let me actually show you the pressure rings. Let me remove this one. 1 second. There you go. Oh, that was a nice sound. So there, remove the wrist ring, and yeah, and this is the pressure ring on the other side. And I'll just remove this. Doesn't matter. There you go. And these are the pressure rings. That's why it is called the pressure ring based LSD. So this thing moves inside of the casing like that, but they can move laterally. And when they expand, because of the movement in the core, like this, when they move outwards like that, it exerts pressure on both clutch packs and locks the whole thing together. And yeah, this is pretty much it. As you can see, my desk is now a mess a little bit. So it's just the whole components, the whole thing is sort of disassembled and everything. But yeah, this is this is how the clutch type limited slip differential, the pressure ring based clutch type limited slip differential works. I hope you enjoyed this video. I know this is a long video, but I try to explain things in detail. So hopefully you understand. If you have any questions regarding different differentials or how this one specifically, let me know in the comments below. So yeah, as always, thank you very much for watching, yeah, see you soon maybe. So thank you.